Alright, in this video we're going to look at some DMA 30 sample questions that you may see on the DMA 30 placement test. And before we jump into them, these are the topics that are covered in DMA 30. Proportions, ratios, rates, and percentages. So you need to be comfortable with solving proportions, working with percentages, rates and ratios, converting between US measurements and metric measurements, as well as just converting between US measurements, such as converting, say, inches to feet, gallons to pints, and then your metric system is like your kilometers, millimeters, milliliters, milligrams, and things like that. And then also a little bit of geometry with similar triangles, which is actually mainly using proportions. Even though this video covers 5 sample questions, you can find more videos relating to all the DMA modules at this website right here. So feel free to visit that. Let's go ahead and have a look at the first problem. During a basketball practice, 2 players, Sadale and Jaron, each attempted 25 free throws. Sadale made 40% of his free throw attempts, whereas Jaron made 52% of them. How many more free throws did Jaron make than Sadale? Sadale definitely made more of them, or definitely made less than Jaron. So, how many more did Jaron make than Sadale? Well, one way to do it, I'm going to show you 2 ways. One way is this. You can just find 40% because each person attempted 25 free throws. So one way of this is we can think we want 40% of 25 is what? This is one way we can think about it. So therefore, now this is a common way of solving these types of problems. 40%, first of all, without a calculator, we need to convert 40% to a decimal. And the way I remember that is I remember D to P, either decimal to percent or percent to decimal. Since we have a percent, we have to convert it to a decimal to do some arithmetic with it. So if we go from a percent to a decimal, we move the decimal 2 places left. That's exactly what I did. Originally, the decimal would have been right here for 40%. Move it 2 places left. That's how I'm getting that 0.40. Now, 40% of 25, the of means multiply, and now we're going to multiply by 25. Is means equal, and it equals what? That's what we're trying to find. So this is going to tell us how many free throws Sadale made because we're going to find 40% of 25. So we have to multiply these things out. Let's take 25 and multiply it by 40. Now you may be thinking, okay, I thought it was 0.40. Well, I can put a decimal down here, but honestly, we just want to think of this as being multiplied as 25 times 40. I'll talk about what this decimal actually does in a moment. So the 0 times 5, 0 times 2, we don't even really need to multiply by 0. However, remember, for a 2-digit multiplication, we got to put a 0 down here, and now we can start multiplying by the 4. 4 times 5 is 20, so we put down a 0, carry our 2. 4 times 2 is 8, plus 2 more is 10. All right, now this is where this decimal comes into play. You want to count, when you're multiplying decimals, you want to count how many places to the right exist to the right of this decimal. Well, we have 2 places that are to the right of this decimal. We have no places to the right of a decimal up here because 25 is understood to be 25 point something. So, all we have is 2 places. Therefore, down here in our answer, we want our decimal to be we want to have 2 places to the right of this decimal down here, so therefore we can say that this is 10. 40% of 25 is 10. Maybe you can do that in your head. Maybe you know a little bit of mental math, and maybe you know that 40% of 25 is 10. So therefore we can say Sadale made 10. 10 free throws. All right, let's go ahead and do the same technique with Jaron. So Jaron made 52% of them. So it's going to be the same type of setup. 52% of 25 is what? So instead, the only difference here, 52% would be 0.52, like here we have the 0.40. So let's go ahead and work on Jaron now. 52%, that will be 0.52. And we want to multiply this by 25. It doesn't matter where you put the 25 at. I'll just put it up top. Now remember that decimal is not really important right now until the end. So multiplying 2 digits, 2 times 5 is 10, 0, carry our 1, 2 times 2 is 4, plus 1 is 5. Let's bring a 0 down before we start multiplying by this 5. So 5 times 5 is 25, put down our 5, carry our 2 now. 5 times 2 is 10, plus 2 is 12. Let's add all this stuff up. So 0, 5 and 5 is 10, 0 carry the 1, 2 and 1 is 3, and then we have 1 right there. So notice up here, how many places do we have to the right of the decimal in 25? Well, the decimal's right here. We don't have any places. How many places are to the right of the decimal in 0.52? 2 places. Therefore, down here, we also want our decimal to be, we want to have 2 places to the right of this decimal. Now, you might be thinking, okay, well, what if we did have like 2.5 up here? What we want to do here, now this is, I'm just trying to give you an example of multiplying with decimals, but had it been 2.5, we would say 1, 2, 3 places. We find the total number of places. Since we have 2 here and 1 here that's to the right of the decimal, we'd want to actually put our decimal here. That's if it was 2.5, but it's 25. So you would be adding up the total number of places to the right of the decimals. But again, like I said, it's just going to be 13 because all we had was 2 places. So therefore we can say Jerron made 13 free throws. Now the question says, how many more free throws did Jerron make than Seidel? Well, Jerron made 13, Seidel made 10. Jerron made 3 more than Seidel did. All you have to do here is subtract. So our answer to number 1 is A. Let's have a look at number 2. So we have a boy. He skis 4 miles down a mountain slope in 10 minutes, but we want to find his average speed in miles per hour over that time interval. So here's the problem though. We want to find the speed in miles per hour, whereas up here we have miles per minute. So let's go ahead and set up that rate. 4 miles in 10 minutes. Now here, this little technique I'm going to show you is called dimensional analysis. And what the whole idea behind this is that we want our final answer to be miles per hour. Well, the miles are already good, so we don't need to change the miles, but we need to change these minutes. And all we have to do is think about, well, how can we convert minutes to hours? Well, recall that 60 minutes is equal to 1 hour. Now, since we want hours to be at the bottom, I'm going to put 1 hour at the bottom, and I'm going to put this 60 minutes at the top. Now, it's important to use words correctly here because, for one thing, if I didn't have these words here, 60 over 1 is 60. But when I say 60 minutes over 1 hour, we can think of this fraction as being 1. We're multiplying by 1. This is called a unity fraction. 60 minutes is the same thing as 1 hour. And another reason why I want you to be careful with your words, yeah, I have hour at the bottom, I have hour at the bottom, but more importantly, we can think about canceling out these words. Since I'm multiplying by minutes at the top and I'm also multiplying by minutes at the bottom, we can cancel them out. As long as we have a word at the top and a word at the bottom and we're multiplying them, we can cancel them out. Just like when you multiply fractions, you can simplify fractions like that as well. Well, look at what happens. What's the only word we have left up top now? Since minutes canceled out, we have the word miles. So 4 times 60, let's say 240, because 60 times 4 is 240, and we have the word miles. So I'll tell you what, I don't even have to write the word miles anymore because I got miles right there. I'll make my fraction bar a little bit longer because, you know, we're where we need to be. Look at the only words you have left at the bottom. Minutes canceled out, all we have is hours left at the bottom. Notice we have an hour over here, which is what we wanted because we wanted to find the rate average speed in miles per hour, and that's exactly what we have here. So 10 times 1 is 10. Let's simplify this fraction. 240 divided by 10. Divide that very quickly. You can cancel out your zeros, or maybe you know that 240 over 10 is the same thing as 24 miles per 1 hour, because 240 over 10 is 24 over 1. Therefore, we can just say 24 mph. That's a common way of listing miles per hour. So our answer here will be D for number 2. Number 3. There are 23 children in a line to buy a hot dog. If every 4th child in line, starting with the 4th in line, gets a toy, what is the ratio of the number of children in line who get a toy to the number of children in line who do not get a toy? Well, here's one way you can do it because this test is not timed. Let's just put, I'm going to draw little lines and I'm going to represent them as children. So 1, 1, that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and I'm going to put one back here at the beginning because I was running out of space. There's 23 children right there in a line. Every fourth child starting with the fourth child in line. So starting from the beginning, 1, 2, 3, 4. I'm going to circle this child because he gets a toy. Next fourth child, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then 1, 2, 3. Notice we don't have another one to circle here. So what's the ratio? Every one that I circled is every fourth child in line. Therefore, we can say 1, 2, 3, 4, 5 out of how many children? 5 out of 23 children get a toy. This is not the ratio we're looking for. We're looking for this is the, I guess you could think of it as percentage. If we take 5 divided by 23, we could get a decimal and then we would say a percentage. But we want the ratio of children in line who get a toy to the number of children in line who do not get a toy. How many children in line do not get a toy? 18 out of the 23 children in line do not get a toy. Look at the ones we didn't circle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Therefore, the ratio is actually 5 children get a toy compared to 18 children who do not get a toy. This answer would be question C. Very tricky because you think it would be B, but this would be the ratio of the number of children who get a toy compared to the total number of children in line. But that's not what we want to find. We want to find the ratio of the number of children in line who get a toy, that was 5, to the number of children in line who do not get a toy. 18 children do not get a toy. So that's the ratio we're looking for. Be careful with that one. That's a little tricky. Number 4, 52 is what percent of 160? Now, recall back in number 1, I said I was going to show you this problem 2 different ways. This is one way of dealing with percents. If you have a percentage of something is what, and if you know the percent and you know the percentage you're taking of this number, you just multiply these together because of means multiply, is means equal. However, I did say I want to show you a different way, and that's what I'm going to do here. Maybe you might like this technique better. This is a little formula, and this is going to be solved using a proportion. Is over of equals our percent over 100. So what we do with this formula here is we just go back and we look for the pieces to plug them in. We want to be careful with the percent at the end of this problem. I know I mentioned D2P earlier. However, we're not going to have to necessarily use that, and I'll explain that in a moment. But is, well, look at this. 52 is, so that goes up top of that first fraction. I'm going to draw my 2 fractions out. What percent? We don't know what percent. If we don't know what percent we have, we use an X there. So notice I'm putting my percent, since I don't know what it is, I'm putting an X in that spot. And then we have of 160. So the of goes at the bottom. We put the 160 down there at the bottom. We always put a 100 in this spot. And now this is a proportion. The way to solve a proportion is to cross multiply and then we're going to divide. Here's what I mean. Cross multiplying 52 times 100. Maybe that's a little bit of mental math. If not, go over to the side and multiply it out. But 100 times 52 is 5,200. That's one cross product. The other cross product, 160 times x, is 160x. And then what we do with these 2 cross products is we set them equal to each other. Now, like I said, the way to solve a proportion is to cross multiply and then we divide. The reason why we divide is because we want to get this x by itself. We're trying to find that x, which represents that percent. And since we're multiplying here, the inverse operation of multiplication is to divide, and we want to divide by 160 because that is going to cancel out these 160s, and that's going to give us that x that we want. If you're familiar with proportions, probably you just go ahead and multiply the 2 numbers that you can multiply right there, and then you automatically divide by this one. And that is how you can do that much faster. And that's exactly what I did here. And I tell you what, we need to simplify this. You could actually go ahead and do long division right now, but I'm not going to. I'm going to at least cancel out those zeros to make my numbers a little bit smaller to handle. So we have 520 over 16 is equal to x. And this is a good time to talk about simplifying fractions. Now, you may think, okay, well, can we divide by 2? Sure, both of these numbers are even. We probably could divide by something bigger, but for now, I'm just going to divide by 2 because there's nothing wrong with dividing by 2. Little shortcut for you on dividing by 2. I know that says 520, but if we take 52 and divide it by 2, well, 2 goes into 5 2 times. 2 times 2 is 4. Subtract, we get a remainder of 1. Bring down that 2. 2 goes into 12 6 times perfectly. Subtract, we get a remainder of 0. Now don't get it twisted. 520 divided by 2 is not 26. 52 divided by 2 is 26. But all we have to do is add a 0. 52 divided by 2 will be 260. 16 divided by 2 is 8. So right now we got 260 over 8 equals x. And again, this is no calculator, so you have to be comfortable with simplifying these types of fractions. Let's divide it by 2 again because they're both even. Like I mentioned earlier, we probably could have divided by something bigger, but hey, you know, sometimes if they're even, just go ahead and divide them by 2. Take 260 and cut it in half. Well, think of taking 26. If you have 26 of something and you divide it by 2, that gives you 13. So 260 divided by 2 is going to be 130. 8 divided by 2 gives us 4. Now, you could stop doing this at any point because we're trying to solve for x, and maybe you're comfortable right here with going ahead and doing some long division. I'll tell you what, I'll go ahead and do that just to show you that we don't have to keep on simplifying since we're trying to find a percent. Well, 4 goes into 13. 4 times 3 is 12. Subtract, we get a remainder of 1. Bring down our 0. 4 goes into 10 2 times. 2 times 4 is 8. 10 minus 8 is 2. And let's bring down, I'm going to put a decimal up here because this is like 130.0, which is the same thing. But we want to bring that 0 down, and 4 goes into 20 5 times, and 5 times 4 is 20. We get a remainder of 0. So in all honesty, 32.5 is what we're looking for. And we do not move the decimal here. I'm going to come back in a second and talk about simplifying this further, you know, just to throw some extra information out there as you're prepping for this test. But the reason why we don't move this decimal here, because that number, 32.5 over 100, think about that. That's our answer. 32.5 is going to be our percent right there. And the reason why that's 32.5 and you see a percent is because 32.5 out of 100 means 32.5% or 32.5%. There's no need to do this D2P since we already had the percent over 100. Be careful right there. Now down here, if you're good with fractions, you can go ahead and skip to the next problem. But nonetheless, suppose you divide it by 2 again to simplify this fraction further. 130 divided by 2 is going to be 65. 4 divided by 2 is going to be 2. So this should give us 32.5 as well. Well, let's do some long division. Let's take 65 and divide it by 2. Well, 2 goes into 6 3 times. It's looking good so far, right? 3 times 2 is 6 minus. We get 0. Bring down our 5. 2 goes into 5 2 times. Uh-oh, looking good. 2 times 2 is 4. Subtract, we get a remainder of 1. I know this is getting sloppy, but hey. Slide that down. This is, again, 65.0, 32 point something. We'll bring down that 0. 2 goes into 10 5 times, and 5 times 2 is 10. We have a remainder of 0. So look at that answer. 32.5, we're getting the same exact thing. You could have done long division here. You could have done long division here. You could have done long division here, and you still would have got that same answer of 32.5 no matter how you look at it. And that's what, so therefore we can say 52 is 32.5% of 160. Let's look at number 5. Jenna is driving at a speed of 65 miles per hour. That might be a good rate to write down. 65 miles per 1 hour. I'm writing it like that, and you'll see why in a second. What is Jenna's driving speed in kilometers per hour? Well, good news there. We had the same units of time. What is Jenna's driving speed in kilometers per hour? And notice there are about 1.6 kilometers in 1 mile. So we're trying to find her speed in kilometers per hour. We're given miles per hour, which is what I have here. We're trying to find our speed in kilometers per hour. So notice our word hour here and our word hour here. We're good with that. What we want to do is we want to get rid of this word miles, and we want to make it become kilometers. This is another example of doing that dimensional analysis. I want to get rid of the word miles, and I want to get the word kilometers. That's where this is helpful. Since we want kilometers to be at the top of our answer, let's put this 1.6 kilometers up top. And let's put the 1 mile at the bottom. Now this is just a rough estimate. It says there are about 1.6 kilometers in 1 mile. Maybe you've noticed the kilometers on your speedometer in your car. You got kilometers and miles. But nonetheless, as I mentioned earlier, if you have words at the top and the bottom and you're multiplying, these words will cancel out because we're multiplying by miles at the top, we're multiplying by miles at the bottom. So go ahead and get rid of those words. Now, what words do we have left? The only word we have left up top is kilometers, which matches that. The only word we have left at the bottom is hours, which matches that. So now the way we find our answer is we just multiply these two fractions together. Take 65 times 1.6. Now remember earlier I multiplied some decimals, and we can think of it as just really 65 times 16, but I'll put my decimal there as a reference or a reminder in a moment. So 5 times 6 is 30, put down our 0, carry our 3, 6 times 6 is 36, plus 3 is 39. Now remember, when we move over to the 1, we got to add a 0. Now we start multiplying. 1 times 5 is 5, 1 times 6 is 6. Let's add this stuff together. 0, 9 and 5 is 14, 6, 3, 9, plus 1 is 10, so we get 1,040. That is what 65 times 16 is. But we want to multiply 65 times 1.6. Remember the decimal places. No decimal places to the right of the decimal up here, 1 decimal place to the right of the decimal down here. Therefore, we want our answer to have 1 digit to the right of the decimal. That's why I'm moving it just 1 place to the left there. So therefore, the 104.0 is the same thing as 104. That's what 65 times 1.6 is. And that should make sense because we're not quite multiplying 65 times 2. 65 times 2, that would give us 130. And notice we're less than 130 because we're multiplying by 1.6. We're not doubling it, not quite. And then the bottom, multiply these together. 1 times 1 is 1. Therefore, a nice way to write this answer is 104 kilometers per hour. I have seen it written like that, but over here they write out the whole words, kilometers per hour. So our final answer there will be B. But there you have it. 5 sample questions that you will probably encounter on the DMA 30 portion of the placement test. Of course, in this video I did not cover geometry of similar triangles. We did look at quite a few of these topics here, but always remember you can find more videos that do cover all these topics at the website listed right here. And that's it for this video. Hope it helped.